Take a look at some log graphs. What I have graphed right here are two different functions, actually technically three. The red graph right here is our exponential function, so f of x. It's b to the x plus a. Now, so b is just going to be some number. We've got sliders there. We're going to change those numbers here in a minute. And then I got my number a, which is a vertical shift if I need to. The other graph is g of x, which is this blue graph right here, which is a log graph. Log base b of x and then minus a. We'll adjust those numbers in a little bit. And I've got the line y equals x as a dotted line. The reason I have this one graphed is I wanted to show you guys that the exponential function and the log function are inverses of each other. There's that symmetry over the line y equals x. So it's kind of a mirror image. So what that means for us is that a lot of the characteristics we have of exponential functions are going to be the same for logarithmic functions, except kind of the opposite. So if we look at our function here, the exponential function, we definitely have a horizontal asymptote. It's going towards negative infinity. It's getting smaller and smaller, closer and closer to zero. What that happens with a log now is it becomes a vertical asymptote. You see it's kind of hugging that vertical, the y-axis versus hugging the x-axis. So what happens if we change some things around? So I'm going to change this b value. I'm going to just slide it a little bit and see what happens. Notice what happens to the graph of the exponential function and the log function. Hopefully you should see them bending kind of the same way or apart from each other. If I go back, I went too far. As I get closer and closer, even as I pass over that line, there's still that mirror image. So what happens now if I change the a value? Now, based on this, I would expect my graph to move up or down, depending on what a is. And here I would expect my graph to move left or right. So let's move it over a little bit. There we go. Let's say at 2. Now what that does is that moves my horizontal asymptote for the exponential function over to 2. But for the log function, it moves my vertical asymptote over to 2 as well. And so the idea here is that we can take effectively a log function by inverting or finding the inverse of an exponential function. That's great and all, but we're not going to take functions, convert them to exponential, graph them, and reflect them over the line y equals x. So how are we going to do this? Well, what we're going to do is we're going to grab some convenient points. So we have a graph right here, y equals log base 3 of x. First thing I want to do is I want to find out the vertical asymptote because I know there is going to be one because it's a log function. And the way I do this, I'm going to take this part right here. That can never equal 0. So I'm going to set that equal to 0 and see what happens. Well, nothing really happens there. I get my asymptote at x equals 0. I'm going to draw that in, and I'm going to draw that in, let's go with like green. That should show up a little bit. Let's go red. That should really pop on the graph here if I make it red. There we go. So I've got my vertical asymptote. So the next thing I want to do is figure out where's my graph going to be. So I'm going to pick 3 convenient points. So here's what I'm going to do. I'm going to set up a table of x's and y's. And now I'm going to take my outputs because I know those are going to be exponents. So I'm going to write that as 0, 1, and 2. And those are just some convenient points that I can pick. And really, this is the function, 3 to the y equals x, if I think about it as an exponential function. So I know the y value, I know my input is going to be a y value. My output's going to be an x. It's really weird to think about, but that's how we're going to approach it. When I plug 0 in here, 3 to the 0 would give me 1. So I'm going to have a point at 1, comma 0. Then I'm going to take my y coordinate 1 and plug it in there. 3 to the first is going to give me 3. So that's an ordered pair of 3, comma 1. And I do the same thing here, plug in 2. 3 to the second would be 9. So I go 9, 2. Now I know what's going to happen is that it's going to kind of bend and hug this line. It's not going to cross over that vertical asymptote. So I expect my graph to do something like this. So our domain is anything past this vertical line. We can't go on this other side. We're going to be over on this side. So my vertical asymptote is right here, 0. So that's where my domain starts. And it's never going to end going to the far right. So it's going to go from 0 to infinity. But we're not going to include any of those points because we never actually get there. As far as range goes, I can hopefully clearly see that this goes down to negative infinity. And as I grow, as I keep going, it's not going to grow very fast, but it is going to grow, and it's going to continue to grow and continue to grow. It's going to go up to infinity for the range. Now contrast that with an exponential function. Let's go back to the graph real quick. The exponential function, we know that our x's were negative infinity to infinity, our domain. Anything, we could plug anything in and we get an answer out. But our range depended on where that horizontal asymptote was. Now with the logarithmic function, we can't plug everything in, but we know that we can get any value out of that. And our input is going to be determined based on where that vertical asymptote is going to be. And so intercepts, we only have one. We had an intercept of 1, comma 0. That's where it crossed the x-axis. Sometimes we will have a y-intercept as well, and we'll talk about how do we figure that out. Looking at our second graph, it's kind of the same idea. We've got log base 2 of now x minus 1. So this is the part that I'm concerned about to begin with. X minus 1, I set that equal to 0, and I get x is 1. That means I'm going to have an asymptote at x equals 1. So just as I did as the last one, I'm going to take my vertical asymptote, I'm going to graph it in red, and so I can see where that graph's going to be. And now I'm going to set up my table of values. So I'm going to do x and y again. And again, my y's, I'm just going to pick 0, 1, and 2 because they seem to be pretty convenient. I'm going to rewrite my function as 2 to the y equals x minus 1, turning that into an exponential equation. So when I try and solve this, I'm going to plug 0 into y again. 2 to the 0 is 1. So I have the equation 1 equals x minus 1. So x would be 2. So I've got a point at 2 comma 0. I'll plug 1 in. 2 to the first is 2. So I have 2 equals x minus 1. X is 3. So 3 comma 1. I'll plug 2 in. 2 to the second is 4. 4 equals x minus 1. So x would be 5. So I have a point at 5, 2. Again, it looks like it's hugging that asymptote right over here on this side. Just a general shape of what the graph is going to look like. Once again, my domain is going to start at the vertical asymptote, which is at 1. It doesn't actually achieve that value, so I put a parenthesis. And it's going to keep on going to infinity. My range, I can achieve any value of y down to negative infinity. It's going to keep on growing. So it's from negative infinity to infinity. And my intercepts, again, I only have one. I have one at 2 comma 0. Let's do some more transformation. So let's look at number 3. Number 3, we've got y equals 1 minus log base 3 of x. So I've got that negative in front. I think that's going to do something. I think that 1's going to do something as well. So I'm going to figure out what that actually is. So first thing I want to do is I'm going to take that x value and set it equal to 0. So once again, I find out that x equals 0 is my vertical asymptote. So I'm going to grab my red pen, draw that vertical asymptote in. Now to create the next part, it's going to be a little bit more complicated to do when I'm trying to find my values. What I'm going to try and do is get it so that I have a nice, easy equation that I can convert to exponential. So what I'm going to actually do is take this log piece and move it over, and move the y over. So I'm really looking at the function log base 3 of x equals 1 minus y. Now at this point, I can rewrite that as 3 to the 1 minus y equals x. So again, I can set up my xy table. So I can pick if I want 0, 1, and 2. So if I plug 0 in, I'm going to get 3 to the 1, which is 3. So I know I have a point at 3 comma 0. If I plug in 1, I'm going to have 3 to the 0, which is 1. So I have a point at 1 comma 1. Something interesting is happening with this one. Then I can plug in the 2 here. Plug 2 into this value. I'm going to have 3 to the negative 1 power, which is 1/3. Now that might not be a convenient point. I'm going to pick another value then. Actually, no, that's probably the best value that I'm going to get. 1/3 I'm going to have to estimate with a y coordinate of 2. 1/3 is going to be right around here at a value of 2. So you can see something's going on that's a little bit strange with this function. What I think is happening is now my graph is going to look something like this. Now I can tell that that is actually going on because of that negative in front. That's going to reflect my graph over the x-axis. So my intercept is still 3, 0. My domain still starts at 0, goes to infinity because it doesn't end. And then my range is still negative infinity to infinity, but it's just kind of backwards because the graph is flipped on its head effectively. All right, one more, number 5. So when I've graphed this one, the first thing I'm going to do is bring that 1 over. So when I set this up, of y plus 1 equals log base 2 of x minus 2. And so the first thing I want to do is find out where is this equal to 0. So x minus 2 equals 0. So x would be 2. That's my vertical asymptote. So I'm going to grab my red pen. X equals 2. Then I'm going to set up my XY table. I've got a function now. I'm going to write it over here since we have the room. 2 to the y plus 1 equals x minus 2. I'm still going to use 0, 1, and 2 because they seem like the easiest points to pick. So plugging 0 in, I'm going to have 2 to the 1, so that's 2, equals x minus 2, so that's 4. So 4 zeros a point. I'll plug in 1, so I'll have 2 to the second power, so that's 4, equals x minus 2, which is 6, 6 comma 1. And I'll plug in 2. 2 to the third power is 8, equals x minus 2, so x is 10. And so I'll have a graph that again kind of hugs the asymptote here. It looks like my domain is going to be from 2 to infinity. My range is from negative infinity to infinity. And my intercepts, I've got one right here at 4, comma 0. So that's how we're going to graph x or log functions. We're going to take the equation and rewrite it as an exponential and plug in y values to find out what x values make it happen after we've already found out where the vertical asymptote is going to be.